All right, everybody, get ready. Because today we are going deep, deep, deep into one of the most common things, but also one of the weirdest things on planet Earth.
Right.
You got it. Water.
Yeah.
The stuff we, drink and swim in and occasionally use to make epic slip and slides.
Right.
But after this deep dive, and all this is thanks to the amazing research that you sent in, you will never look at a puddle or a pool or even just a glass of water the same way again.
It's true. What's really fascinating about water is that we kind of take it for granted, but it does all of these really strange things that almost defy logic.
Right.
It's almost like it's hiding something, some kind of secret power or potential that we haven't fully figured out yet.
Okay, let's start with something that I think we all learned in, elementary school.
Yeah.
Ice floats.
Right.
But, how many of us have actually stopped and thought about, why is that?
Yeah.
Most things get denser when they freeze and they just sink like a rock.
Right.
But not water.
Not water, no. It all comes down to water's really strange molecular structure.
Yeah.
As water molecules slow down when they freeze, they form this, they arrange themselves into this kind of crystalline lattice with more space between them than in liquid water.
Okay, hold on. Crystalline lattice.
Yeah.
Could we maybe break that down for those of us who haven't had a chemistry class in a while?
Sure. You can imagine water molecules like tiny little dancers, and in liquid form, they're all kind of moving around freely, bumping into each other, like chaotic waltz or something.
Okay.
But when they freeze, they suddenly link arms and have to form this very specific pattern, like a square dance.
Okay.
And because they're holding each other at arm's length, they end up taking up more space.
So it's kind of like going from a mosh pit to a very organized line dance.
Exactly.
Okay.
Yeah.
Got it. But honestly, who cares if ice floats?
Yeah.
Well, it turns out it's a pretty big deal.
It's a really big deal. If you think about it, if ice sank, then lakes and oceans would freeze from the bottom up, right? That would mean no ice fishing, no polar bears lounging around on icebergs, probably a lot fewer penguins.
Yeah. And not to mention, all the life that lives under the water.
Right.
That floating ice acts like a giant insulating blanket that protects all those ecosystems from, the really, really harsh cold.
Right.
So thank you, weird water molecules, for making life possible.
Not for real.
But it gets even weirder.
Oh, yeah.
Scientists have actually created something called supercooled water.
Supercooled water, right. That's where liquid water can actually exist in temperatures well below freezing, which is just kind of crazy if you think about it. The current record is netish of 48 degrees Celsius. Wow. That's unbelievably cold.
Yeah.
Below that, the water molecules just can't help but form that crystal lattice anymore.
So they're playing a game of freeze tag.
Yeah.
But they keep dodging until they can't dodge anymore.
Exactly.
And then the ice that forms at those really low temperatures is even weirder.
Yeah.
It's not that nice organized ice that we're used to.
Right.
It's this chaotic, jumbled mess that kind of blurs the line between solid and liquid.
It really challenges our definition of what a solid is and what a liquid is.
Right.
It's almost as if the water is saying, I don't have to play by your rules, humans. Yeah. I'm going to do what I want.
Water. The ultimate rebel.
Yeah.
But that's just the tip of the iceberg, so to speak.
Right.
Because here's where things get really, really interesting.
Okay.
Some research suggests that water might actually exist as two different liquids that we just haven't figured out how to separate yet.
Isn't that wild?
Yeah.
It really does sound like science fiction.
Yeah.
But there's this growing body of evidence that water molecules can actually arrange themselves in two different distinct structures, even in liquid form.
So it's like having two different dance floors in the same club.
Yes.
Each with its own vibe and its own moves.
That's a great analogy.
Yeah.
And maybe this idea of two waters connects to some of these ancient stories that talk about different kinds of waters existing on Earth, maybe with special properties or mystical powers.
Okay, now we're talking
right.
Ancient secrets and hidden powers.
Yeah.
But even more recently, there's this research suggesting that water goes through some major personality changes, somewhere between 40 and 60 degrees Celsius.
Yeah. It's true. This is cutting edge research.
Yeah.
But it suggests that water's behavior just shifts significantly in that temperature range. And it makes you wonder, what if there is something special about water at those temperatures that we haven't fully understood or tapped into?
Ooh, a hidden potential waiting to be unlocked.
Yeah.
Okay. I'm already getting goosebumps.
I know.
But before we dive deeper into that rabbit hole, I have to tell you about someone who was absolutely obsessed with water in a totally different way.
Oh, okay.
Have you ever heard of Wilson Snowflake Bentley?
Oh, the snowflake guy.
Yes, the snowflake guy.
Yeah, the guy who took all those pictures of snowflakes?
Yeah.
Yeah.
So imagine this. You're 15 years old. You get a microscope for, I don't know, a birthday present or something. Yeah. And you become totally consumed by the beauty of snowflakes.
Okay.
And we're not talking like a casual hobby, right?
Right.
This guy spent 51 years photographing snowflakes.
Wow.
Over 5,300 photos. Each one totally unique, capturing all these like intricate details and the fleeting beauty of these frozen wonders.
It's amazing. It's a testament to how much diversity there is in nature,
Yeah.
even at the microscopic level.
Right.
Each snowflake is a product of its own unique journey through the atmosphere, and temperature, humidity, even little tiny dust particles all affect how it forms.
Yeah, it's kind of mind-blowing to think about, right?
It is.
Each snowflake, a tiny little masterpiece, never to be repeated.
Right.
It's like a metaphor for life.
Yeah.
Unique and fleeting and beautiful in its own way.
I like that.
Okay, now for the snowflake zen moment.
All right.
Let's zoom out to the big picture. Where did all this water come from in the first place?
Ooh. That is the question, isn't it?
Yeah.
One of the biggest mysteries in science.
Right.
There are two main theories. One is that Earth just formed with all this water already trapped inside like a giant cosmic water bottle.
Okay.
The other is that water arrived later, delivered by comets or asteroids or even interstellar dust.
So Earth came with its own built-in hydration system,
Yeah.
or it got a cosmic delivery.
Right.
But if it was a delivery, where did those sources get their water?
Exactly.
It's like this never-ending game of cosmic water tag, like who started it?
Right. It's a question that leads us all the way back to the origins of the solar system and even the universe itself.
Right.
It makes you wonder if maybe there's more to the story than we currently understand.
Ooh, a cosmic conspiracy.
Uh-huh.
Ancient aliens seeding the Earth with water.
Maybe.
All right, I'm officially intrigued.
Yeah.
But speaking of ancient mysteries, let's take a little trip down to Mexico to the Tula ruins.
Okay.
These ruins were built by the Toltec people, who were known for being incredible craftspeople.
Right.
But there's something kind of strange about some of the statues that they left behind.
Oh, are you talking about the statues on the Pyramid of the Morning Star?
I am.
The ones that look like
The ones that look like warriors.
warriors with guns.
With guns. These guys are decked out in what looks like some serious futuristic gear.
Yeah.
They got headsets, chest plates, and they're holding these like long cylindrical objects that look suspiciously like high-tech weaponry.
It's true, they do.
And here's the really wild part. Local legends describe them as wielding weapons powered by, you guessed it, water.
Water weapons.
Water weapons.
Ow.
I know, right?
That's a story I want to hear more about.
We're just getting started. And trust me, things are about to get even more mind-boggling when we come back for part 2 of our deep dive into the mysteries of water.
Welcome back to our deep dive into the mysteries of water. Remember we were just talking about those strange warrior statues at the Tula ruins in Mexico?
The ones that look like they stepped right out of a sci-fi movie with all their high-tech gear and what looks like water-powered weapons.
It's a pretty captivating image. I mean, these statues, they really make us rethink what we thought ancient civilizations were capable of.
Right.
Like, if those local legends are true,
Yeah.
it suggests they were way more technologically advanced than we give them credit for.
I mean, water guns that can cut through stone? Come on.
Yeah.
It sounds like something straight out of a comic book.
It does.
But what if there's more to these stories than we realize?
Yeah.
What if the Toltec people, or maybe even a civilization before them, had a way better understanding of water's true potential than we do now?
It's an interesting thought.
Okay, let's put on our speculative hats by a second
Yeah.
and really entertain this idea. If these water weapons were real, how could they possibly work? What kind of technology could harness the power of water to such a, destructive degree?
Well, we know that water is made of hydrogen and oxygen, right?
Right.
And both of those are really reactive elements.
Yeah.
So under the right conditions, maybe involving a ton of heat or pressure, it's possible that water could be, I don't know, manipulated to release a crazy amount of energy.
So are we talking like some kind of superheated steam cannon?
Yeah.
Or maybe they found a way to split the water molecules apart and create like a mini hydrogen bomb?
Those are some interesting ideas for sure.
Yeah.
The legends say that these weapons could cut and even melt stone,
Right?
so that would mean they could manipulate matter on a molecular level,
Wow.
which is something that we're only just starting to be able to do with our modern technology.
It makes you wonder what other secrets might be buried out there just waiting to be rediscovered.
It really does.
But if these ancient civilizations did have this super advanced knowledge of water, where did they get it from?
That's a great question. Like, were they just super geniuses who figured it out through trial and error?
Right.
Or did they get this knowledge passed down to them from an even older civilization?
Mm-hmm.
Maybe even one with, well, let's just say non-terrestrial origin.
Oh, I knew you were going to go there.
Yeah.
Ancient astronauts sharing their super advanced technology with early humans. It's a classic theory, and who knows, maybe there's some truth to it.
Right.
But let's not get too distracted by the aliens just yet.
Okay.
Remember that massive explosion in Siberia back in 1908?
The Tunguska Event.
Yeah, the Tunguska Event.
Oh, yeah, that was a weird one.
An explosion with the force of, like, 1,000 atomic bombs.
Yeah.
But no crater, no radioactive fallout, and no one really knows what caused it.
It's true. It's one of the biggest mysteries of modern history.
And didn't you say that water could be the culprit?
I did.
But how does water cause an explosion that big?
Well, it's a controversial theory for sure, but it's got some interesting evidence to back it up. Okay, so imagine a huge icy meteoroid entering the Earth's atmosphere.
Okay.
As it's falling to Earth, friction creates a lot of heat.
Right.
And that causes the ice to vaporize into superheated steam.
Okay, so we got a giant steaming space rock heading for Earth.
Right.
What happens next?
Okay, so now imagine that this superheated steam reaches a critical temperature and pressure.
Okay.
In those extreme conditions, the water molecules could actually dissociate, which means they would split apart into their basic hydrogen and oxygen atoms.
Wait a minute. It's not like the same process that powers the sun? Nuclear fusion.
It's not exactly the same.
Okay.
Nuclear fusion is when the nuclei of atoms merge together.
Right.
And this is more like splitting water molecules apart.
Okay.
But it's a similar idea. They both result in a massive release of energy.
So we're talking about a giant icy meteoroid turning into a giant hydrogen bomb in midair.
Basically, yeah.
Okay, that would explain why there's no crater.
Yeah.
But wouldn't there be some evidence of the water?
Not necessarily. The explosion itself would probably vaporize all the remaining water, so there wouldn't be much left behind except for flattened trees and scorched earth.
It's a pretty wild theory, but it kind of fits, you know?
It does.
Here's a question that's been bugging me, though. If water does have this explosive potential, why don't we see Tunguska-like events happening all the time?
Good question.
I mean, Earth is basically covered in water.
Yeah, but the conditions needed to create an explosion like that are super rare.
Okay.
You need just the right amount of water, the right temperature, the right pressure, and maybe even certain catalysts or energy sources that we don't know about yet.
So we're not all just living on a giant water bomb waiting to go off.
Probably not.
Yeah, that's good to know. But it makes you think, right?
It does.
If those ancient legends about water weapons are true, and if water was responsible for the Tunguska event, what other secrets does this seemingly simple substance hold?
Well, that's something people have been wondering about for centuries. Like, what if the key to unlocking a whole new era of energy, technology, and maybe even space travel is hidden within the water we drink every day?
All right, welcome back to our final deep dive into the incredible, sometimes really weird world of water. We've looked at everything from ice doing its own thing to ancient stories about water weapons. We even talked about the possibility of, water explosions.
It's been wild, right? And it all started with that simple question, what is water, really?
Yeah. Turns out it's way more complicated and mysterious than most of us realize.
Right.
We've seen that water basically makes its own rules, doesn't really care about what we think should happen.
It does its own thing.
Yeah. But here's the thing that I keep thinking about. What does all this mean for us going forward? I mean, if water has all this crazy potential, how can we actually use it?
Well, that's the million-dollar question, isn't it? Researchers all over the world are trying to figure that out.
Yeah.
What if we could harness the energy that's released when those water molecules split apart? We're not just talking about a new energy source here. We're talking about clean, abundant energy that could change, like, everything.
Imagine cities powered by water, cars running on hydrogen that we get from plain old H2O.
Right.
No more fossil fuels, no more pollution, just clean, sustainable energy like right out of the faucet.
It sounds pretty futuristic, I know, but the science is there.
Yeah.
We already have the technology to split water molecules using electrolysis.
Right.
The hard part is figuring out how to do it efficiently and cheaply on a really big scale.
So it's not a matter of if, it's a matter of when.
Exactly.
I can practically see a future where water is the fuel that runs our houses, our cars, maybe even takes us out into space.
Speaking of space, water could be really important for exploring other planets.
Yeah.
It's basically essential for life as we know it. Plus, it can be used to make breathable air, fuel for spacecraft, even building materials for habitats on other worlds.
It's like water is the ultimate Swiss Army knife for space explorers.
Mm-hmm.
And it's already out there, like frozen on moons and asteroids. We just need to figure out how to, I don't know, how to mine it and use it effectively.
Right.
But it's not just about space travel and all this futuristic technology.
Yeah.
Water is also the key to fixing some of the really big problems we have right here on Earth.
Definitely. Think about water scarcity. It's a huge issue in a lot of places.
Right.
But imagine if we could come up with better ways to purify and desalinate water, like really efficiently.
Yeah.
We could turn deserts into farmland, make sure everyone has access to clean drinking water, and create a more sustainable future for everybody.
It's crazy to think that the answer to so many of our problems might be right there in front of us, in the stuff that covers, what, like 70% of our planet.
Mm-hmm.
It's like we've been looking at the answer this whole time without realizing it.
It shows how much we still have to learn from nature, even from the things that seem super basic at first.
Yeah, well said.
Water is powerful. It's essential for life. And maybe, just maybe, it holds the key to a better future for all of us.
Well, that's about it for our deep dive into the fascinating world of water. Any final thoughts before we sign off?
Just this. Don't underestimate water. We take it for granted, but it has the power to change the world in ways we can't even imagine yet.
Couldn't have said it better myself. It's been an amazing journey exploring all the weirdness and the possibilities of water. From its strange properties to its potential to power our future, water is definitely a force to be reckoned with. So next time you're having a glass of water, remember you're not just quenching your thirst, you're experiencing something truly amazing. It's a substance that holds the secrets to life, energy, and maybe even the future of our planet.
Absolutely. Keep asking questions, keep exploring, and keep being amazed by water.
And that's a wrap on our deep dive into the amazing world of water. Until next time, stay curious and stay hydrated.